Hello again. Welcome back to day 9. Musical soundtrack, which you cannot hear. Sorry about that. Synchro Anarchy by Voivod. Listen along at home if you'd like. Let's see what the day 9 puzzle brings us. All right, rope bridge. Da, 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 da. Okay. Which way should you walk along the archer? Okay, seems to support the L's just fine. Step carefully, stretch and twist, decide to track yourself in modeling rope physics. Consider a rope with a knot at each end. These knots mark the head and the tail of the rope. The head moves far enough away from the tail is pulled towards the head. Maybe this reason involving plank links, you should be able to model the positions of the knots in two-dimensional grid. Then by following a hypothetical series of motions, your puzzle input, that you can determine how the tail will move. Due to the aforementioned plank links, rope must be quite short. In fact, the head and tail must always be touching, diagonally adjacent. Okay. The head is every 2 steps directly up, down, left, or right from the tail. The tail must also move 1 step in that direction. Okay. Otherwise, if the head and tail aren't touching and aren't in the same row or column, the tail always moves 1 step diagonally to catch up. Okay. You just need to work out where the tail goes as the head falls. Assume the head and tail both start at the same position, overlapping. All right, 4. Down a step, okay. So it's right 4 steps, up 4 steps, left 3 steps, down 1 step, so on. After each step, you'll need to update the position of the tail. Step means the head is no longer adjacent to the tail. This occurs the following. So head covers tail, okay. Tail covers S. S must be start. Okay. Sure. We're going to come back and look at that again. After simulating the rope, you can count up all the positions of the tail visited at least once. This diagram, S marks the starting position where the tail, here's where the tail is visited. All the positions, there are 13 positions the tail visited at least once. Simulate your complete hypothetical series of motions. How many positions does the tail of the rope visit at least once? Okay, so this is our input. Right? And the rules are, these are the rules. Okay, so these are the rules. Let's put the rules here. That's that rule. Otherwise, if the head and tail aren't touching and aren't in the same row or column, tail always moves diagonally to catch up. Okay. So, our input is essentially direction and a distance, right? So for every one of these lines, we are going to say, we're going to say select direction is line sub 0 and distance is going to be int parse. No, it's not even going to be int parse. It's always a single digit, I think. We'll see. Let's go look at our puzzle input. It's always a single digit. It looks like it is always, oh, no, there's definitely cases where it's 2 digits. Okay. Line 2. So this is going to be int parse line sub 2. Close one more parenthesis, please. That'll give us an array of character of distance and int Vector of direction and int of distance. Okay. So the first thing we need to do is we need to follow all these things, right? So we're gonna say tail x is 0. We're gonna say, yeah, tail x is 0, tail y is 0. Head x is 0, head y is 0. It doesn't really matter what the things are because we don't actually care about the actual positions. We're going to need to know a list of visited positions. So we're going to need visited, tail visited. It's going to be a new hash set of int. Okay. Tail visited add 0, 0. What are you telling me? I can simplify that. Sure, why not? Okay, so we start there. So for each var instruction in data, we say switch instruction direction. All right, case right, case left, case up, case down. Default, we will throw a new invalid operation. Okay, so if we're going right, that means head x double plus. If we're going left, that means head x double minus. All right, up is going to be head y double minus, and this is going to be head y double plus. And then everybody here that needs to, Brad, everyone here that needs to break. All right, we're going to say while instruction dot see var count is instruction dist. And we're going to say while count is greater than 0, we're going to do all of this. Right, we're going to make sure to decrease the count on the way through. Okay, so given that, then we want to say we have 3 situations, which is we're already touching, right? We have same row or column, but 2 away, and then we have diagonal. Let's see, not same row or column. Those are our 3 situations, right? So if we're already touching. So we'll do this. We'll say dx is head x minus tail x. dy is head y minus tail y. So if dx is 0, else if dy is 0, else. Okay, so this third else is this, right? These two could both be already touching, but not in the same row. So dy is, yeah, if dy is -1 or dy is 1, let's do it this way. We'll do not equals, right? Not equals -1, then we have to do something about it. Same down here, except it'll be dx, right? So if all right, so we'll figure that out here in a second. All right, so if So if we're in the same row, actually it might be easier to do this. So if dy is 2, else if dy is negative 2. That's the two situations we care about, right? So if head y is 2 further along, then we just want to do tail y plus plus. Otherwise, we're going to do tail y minus minus, right? So we want to do the same thing down here, except we want to do it with x. Tail x, dx, tail x, right? Now, here we're going to have the situation where one of them is going to be 1 or negative 1. The other one's going to be 2 or negative 2. Which is kind of the same things that we've got going on here. Which I guess if we think about it, right, this looks like, for example, if dx is 2 and dy is 1, then that means we would want to add 1 to each, right? So if we just add dy to each, if we add 1 to tail x and dy to and dy to tail y, that's going to cover both of these. Yeah, let's do that. So we should just be able to do it like that. And we'll just do this with an else. All right, that's going to do everybody. So here we're going to say this is like this, and we're going to say tail x plus equals dx. And we're going to say tail x plus equals dx. We're going to say tail y plus equals dy. Right, and then we're going to say tail y plus equals dy. And then last, since we're going to start printing things out because I'm about 5% sure that I've got all this correct, we're going to see what's going on here. So didn't move the tail. That's what we're going to say, right? So we're going to say console right line moved. Let's see, we're going to say dy was 2. Head, actually, let's do this. All right, let's do this. Console right line. Head is, let's do this. Head is head x, head y. Right, we're going to write this. Dx is dx, dy is dy. Tail, yeah, we'll just write the tail down here, that's fine. Tail x, tail x, tail y. Right, and then count. So every time we move this, we also need to make sure that before we do that, we're going to do tail visited set. Is it just add? I guess it's just add. Okay, so we add tail x, tail y. Visit count is tail visited count, right? Let's see. We're also going to do this, which is we're going to write the instructions. Instruction. Yeah, we'll write the instruction. Okay. And then the result is actually the tail visited count. Tail visited count. All right, let's see what happens here. All right. Let's move you over here, right about there. Let's go take a look at this data again, right? Because we're going to follow along over here. So the initial state is that we're at 0, 0. So we moved right, that goes 1, 0. The tail is still at 0, 0 with still a visit count of 1. We move the head to 2, 0, which means we move the tail to 1, 0. 3, 0, 2, 0, 4, 0, 3, 0. Head visit count is 4, right? 4, negative 1. That's going to be this. 4, negative 1. So that means the tail, head, tail. So the tail doesn't move because they're still next to each other. Yeah, 1 and negative 1, that's okay. So when we're now at 4, negative 2, which means the tail now goes to 4, negative 1. Yeah, 4, negative 1. This all looks like it's doing the right thing. So 4, negative 2, 4, negative 3, 3, negative 4 stays at 4, negative 3. Yeah, that all looks okay. So then 4, negative 3, 3, negative 4, yep. 2, negative 4. You move down, you stay at 2, negative 4. You move over, stay at 2, negative 4. You move over, stay at 2, negative 4. Move over 1, which means you're now at 3, negative 3. We move over 1 more, 4, negative 3. All right, and then down once, you stay. This all looks good to me after simulating this. Okay, 13 positions visited at least once. All right, well, let's try the real input. I think, man, that's a lot of console write lines, but we'll just let it go. 6284, 6284, 6284. Okay, part 2. A rope snaps. Suddenly the river is getting a lot closer than you remember. The bridge is still there, but some of the ropes that broke are now whipping toward you as you fall through the air. The ropes are moving too quickly for you to grab. Only a few seconds to choose how to arch your body to avoid being hit. Fortunately, your simulation can be extended to part long rope. Rather than 2 knots, you must now simulate a rope containing 10 knots. 1 knot is still the head of the rope. It moves according to the series of motions. Each knot further down the rope follows the knot in front of it using the same rules above. So we now have 10 tails. Now, if you keep track of the positions of the new tail, now you keep track of the positions the new tail 9 visits. In this example, the tail never moves, so it only visits 1 position. Isn't that interesting? Here's a larger example. All right, so we need 9 tails. So we need, now I need to do this with 9 tails. Okay, so I'm all right with that. Let's come down here. Let's get that there. Let's put our old data back. All right, so we need a bunch of tails, right? New list of int. These are our tails. These are our tails, right? And then we say 0, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Oh, these are supposed to be. Yeah. All right, so those are our 9 tails. Head is 0, 0. Okay, so here's what we're going to do then. We're going to take all this move logic, right? We're going to take all this move logic and extract it out into a function. Yeah. Okay, yeah, we're going to do this. So let's do, what's the best way to do this? We're going to say void move. We're going to take an int and an int, which is the leader, and then a ref int is the follower. I don't know if ref is going to work. We'll see. All right, so that's the logic. So this is leader. So you're going to be X, and you're going to be Y, and you're going to be X, and you're going to be Y. All right, so you're going to be leader X, follower X, you're leader Y. Whoops, you're going to be follower Y. And we need an instruction, right? So we need a direction is what we need. No, we don't. This is just the moving the follower after the leader's already moved. Follower Y, double plus, follower X, follower Y, follower X, follower X, follower Y, follower X, follower Y. So that should be move a follower, right? So instead of this, tail visited is fine. We're going to take this, we're going to move the head based on the direction, right? And then we're going to move the follower from the head to the tails sub-0, ref tails sub-0. Is that going to work? No, that's not going to work, is it? Property index may not be passed. All right, that's fine. So we'll do this. We'll do tails sub-0 is this, and then you don't have to be a ref. We're just going to pass a result back. All right, so we're going to say var result is follower. And then this is going to be result, 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 return result. All right. So then we're going to say move this follower. All right, then tails 1 is going to be moving tails 0 to tails 1. 2, 3, 4, 5, 6, 7, 8, 9, right? 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, 9. This is going to be head dot x and y, head dot x, x, y. Come on, don't be like that. X and y, x and y, x and y. Okay. Well, that's fine. So then tail visited. So I don't need any of this logic, right? We're going to take this and we're going to say instructions. That's head x. That's head y, dx, dy. We don't actually care about that anymore, right? And then we're going to get rid of all of this. This is going to be tails 9, x, tails 9, y. Actually, this is just tails 9. This is already set up to take the right type, right? Tail is tails 9, x, tails 9, y, and then a visit count. And then up here, we're going to comment out these console writes and write lines because we don't care about that. We should end up with 0. Index out of range. Really good item on the list. Oh, that's too many. That's why. We only have 9. We don't have 10. We have 9, which means we finish at 8. So the visit count stayed 1, which is what we knew was going to happen. They said, here's new data, right? Here's some new data. So given that, we get a visit count of 36. Let's just see if that's right. Okay. 36, okay, looks good. So let's go back to our full, oh, we need our full data again. Where's our full data? Grab the full data. All right, and let's see if this works. 2379. 2379. Oh, not the right answer. Interesting. Okay, not the right answer. Okay, so if that's not the right answer, then it's interesting that we got the correct answer with the complicated data. Okay. Let's take a look at this. Up here. So we moved right 5. The tail is still at 0. We move up 5 more times. Move up 5 more times. So 9 still covers S. But when we moved up 8, that's interesting. So we don't end up in the same place. All right, what if we try and print this out then? So let's say printing helps us. Let's print. What is the easiest way to print this? All right, let's not print these instructions. Let's print this, which is console right line. Head is head X, head Y, console right line. Tail 1 is tails 0x, tails 0y. All right, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that prints us out after every step. Let's take a look here. All right, let's compare that against what we should be seeing here. Right, so we've got head at 5, 4, 3, 2, 1, 5 is at 0, and everybody else is still covered. So here we've got head at, you think the start is here, right? So that's 1. Right, that should be 5. -1, 2, it should be 5, -8. Yeah, duh. Should be 5, -8. 5, -7, 5, -6, 5, -5. -8, -7, -6, -5, -4, 4, -4. Interesting. 4, -3, that's where you think 6 should be? That doesn't seem right. 4, tail 5. Is it 4, -4? That's right, 4, -1, 2, 3, 4. 6 should be at 3, -3. So how did these guys get moved? 3, -3. All right, well, let's just do these 2 sets of instructions then. And then let's put these here again. And then let's see if we can figure out what's going on here. Okay. So 1, 2, 3, 4, 5. Tail hasn't moved. Here's what we're going to do. We need more data than that, right? We need this. We need instruction dot direction. That's what we need. We need head and then we need each of the tails. That's really what we need. So we're going to do this to each one of these. All right, we're going to do console.write tails 0x, tails 0y. Hey, cut it up. One, two, three, four, five, six, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. You're going to be a right line, and you're not going to have an arrow anymore. And we don't need parentheses there anymore. Let's do this. Okay, that's the data we're looking for now to make sure we're making all the right moves. Okay, so right. 1 doesn't move anybody, 2 moves 1, 3 moves 2, 1, 4 moves 3, 2, 1, 5 moves 4, 3, 2, 1, nobody else moves. That part's okay. So then we come down here and we go, you go to 5, negative 1, which then you don't move because you're still diagonal, which means nobody else moves, right? Then you go up, which means you are now 2 above and 1 to the right. So you need to move right 1 and up 1, which you do. Which means you are now 2 off, so you need to move diagonally as well. Right 1 up 1, right 1 up 1, right 1 up 1, right 1 up 1. You're still here. That's okay. So we go up, so you don't have to move because is this right? When you're 5, negative 1, and you're 4, 0. Oh, right, you didn't move then. You moved the second time. And that's the diagonal move. So then this now, because you're going up, right? If I look at it like this, you're moving up. First time you move up, nobody else comes up. First time, then you move up, you move over here. Wait a minute, you move up, you move up, you move over here, which means you have to move. All right, I need Notepad here, right? Because they're missing all the independent steps. So we're in 5, 4, 3, 2, 1, H, right? And then as soon as we move to H, you're fine, right? And then we move H again. We move H here, which means 1 has to come here, which means 2 has to move diagonally. So 2 has to move here, right? Which means 3 has to move here, which means 4 has to move here, which means 5 has to move here. And now this is still 6, 7, 8, 9, right? And that's what we saw here. That's this. So 1, 2, 3, 4, 5 all moved up a row and over 1. 6, 7, 8, 9 are still sitting there. Okay, so now H moves up again. All right, so now H moves up again. So now 1 has to come here, right? Which means 2, 3, 4, 5, 6, 7, 8, 9 all stay in the same place. So far, so good. Okay. H now moves here, which moves 1 there, which moves 2 there, right? Which then moves 3 here, which then moves 4 here, right? Which then moves 5 here, which then moves 6 here, which then leaves 7, 8, 9 there, right? So now we're here. So we've got 1, 2, 3. So this is this line here. 5 and negative 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, right? And then negative 1, negative 2, negative 3, negative 4. Okay, so we're on this line here. We're on this line here. So then we've got 5, negative 3. Yep, and then we've got 4, negative 2. Man, that doesn't seem right though, does it? Because if I'm on 5, negative 3 and 4, negative, oh, that is correct. Hang on, back up. Let me do this. All right, so if that's like that, then 2 moves here. Wait a minute, we're doing this one. Stop looking at the wrong one. All right, so that's 2, which means that's 3, which means that's 4, which means that's 5, which means that's 6, which means that's 7. Right, we're here. So 5, negative 3, 5, negative 2, 4, negative 2, 3, negative 2, 2, negative 2, 2, negative 2. Wait a minute, 2, negative 1. That doesn't seem right. How did you get from 0, 0 to 2, negative 1? Because you were 2, negative 2. That's 6. So the step for 6, right. We can't move 2. That's the problem. We're moving 2. All right, I see the problem. So the problem is the move here just moves you by dy. And so this is going to be dx greater than 0, 1. Otherwise, dx less than 0, negative 1, negative 1, otherwise 0. That's the problem. We were moving 2 when we shouldn't have, right? And so now I need to write this exactly like this. So if you're greater than 0, you get to move 1. Come on, you get to move 1. Otherwise, if you're less than 0, you get to move negative 1. Otherwise, you move 0. Okay. Now if I run this, that puts us here, which puts us at, let's go take a look at our graph here, right? So we're at 5, negative 8, 5, negative 7, 5, negative 6, 5, negative 5, 5, negative 4, 4, negative 4, 3, negative 3, 2, negative 2, 1, negative 1, 0. Okay, I think this is better now. So let's run this again, and you get 36, which is what we said we should get, which is 36. Now let's run it with our real data. And we're going to print out an infinite amount of nonsense and wait for the infinite amount of nonsense for 2661. 2661. There we go. Okay, yep, there we go. That was it. A little bit more challenging than expected there. Just mostly because, of course, I had an algorithm that worked with one version of the data, but not with both versions of the data. I mean, that's sort of the way it works. And we debugged our way through, so we're good. 45 minutes for day 9, or 43 minutes, sure, whatever. Not too bad. So I guess that's it for today. I'm going to clean this up so that part 1 reuses this move function, and I guess I'll see you tomorrow.